Hello, myself Mrs. C.S. Nirali, Assistant Professor, Food Chemistry and Nutrition Department, KKV College of Food Technology, Saraswati Nagar Campus, Nashik, under course number FCN 357, Instrumental Techniques, course title Instrumental Techniques in Food Analysis. Today we will see experiment number 6, title Analysis of Heavy Metal Using Atomic Absorption Spectrophotometer. Introduction. This experiment consists of preparing a series of standard solutions containing the element to be determined, iron in this case, and preparing solution of metallic alloy samples and measuring the absorption of light by the atoms of the different element when the solutions are aspirated into a flame. Normally, the alloy samples are dissolved in a acid directly. The concentration of the element in the sample solution are determined from curves of absorbance versus concentration determined by measurements on standard solution by the spectrophotometer. Principle: atomic absorption spectroscopy is a spectroanalytical procedure for the quantitative determination of chemical elements employing the absorption of optical radiation light by free atoms in the gaseous state. In analytical chemistry, the technique is used for determining the concentration of a particular element, the analyte, in a sample to be analyzed. It requires standards with a known analyte content to establish the relation between the measured absorbance and the analyte concentration and relies therefore on the Beer-Lambert's law. Principle: in short, the electrons of the atoms in the atomizer can be promoted to higher orbitals excited state for a short period of time, nanoseconds, by absorbing a defined quantity of energy radiation of a given wavelength. This amount of energy, that is wavelength, is specific to a particular electron transition in a particular element. The radiation flux without a sample and with a sample in the atomizer is measured using a detector, and the ratio between the two values, the absorbance, is converted to analyte concentration or mass using the Beer-Lambert's law. The pictorial representation of AAS is given side by, and the sequence of path length of a reaction procedure used in this AAS is given in the second picture. Atomic absorption spectrophotometer. In this, first ionization takes place, next sputtering, next excitation, next emission. And this is the light source, the second picture, and this is the whole picture. Here the light source, so next to chopper, next to sample cell or flame for fumace, monochromator, detector, water. Procedure: preparation of standard iron solution. 5 standard solution ranging from 2 to 6 micrograms per ml in 100 ml volumetric flask. One of the solution should contain 5 micrograms per ml. That is used to check the performance of the instrument to make up the 5 standard solution. Make stock solution 0.1 grams per 1000 ml and dilute a liquids. Clean the iron wire and dissolve in a minimum amount of concentrated nitric acid and water in 1:1 ratio, volume by volume. The heating will be necessary to dissolve the wire. Transfer the solution quantitatively to a 1000 ml volumetric flask and dilute the volume with distilled water. Preparation of sample solution. Prepare the sample solution in a 100 ml volumetric flask. Dissolved each weight sample in a 250 ml beaker with 1:1 volume by volume mixture of concentrated HCl and water. If necessary, then add the mixture of nitric acid and water. Preparation of the instrument. An iron lamp has been installed in the instrument. Open the vent door for the exhaust above the instrument. Set the monochromator to 48.3 nanometers. The slit width will be 0.5 and slit height to high. Turn the instrument on. Press the entry function key. Enter 30, that is the operating current in milliamperes for the iron lamp. Integration time. Each measurement will be made for 1 second. The range allowed from 0.1 to 60 seconds. Replicates. Each measurement will be made for 5 times. Then enter 5. It is allowed 1 to 99 times. Atomic absorption spectral technique enters 1 for flame, enter the concentrations of standards, enter for optimize the power reaching the detector, press energy and adjust the wavelength, adjust the power outlet and pressure, ignite the flame. Measurement of absorbance. Manual calibration is done, automatic calibration is done. Shutdown. Data interpretation. The data can be represented in short report. The short report is a print out of any calibration graphs. A simple statistical check is performed and the standard deviation calculated. Result also include the different integration time and the number of replicates. Result will be obtained, which will be shown on the screen, as well as we can get the printout. Precautions to be taken while using AES. Wear the safety goggles while you are dissolving your sample. Before the ignition of flame, put the goggles and continue to wear them till you are working at a flame. In the fuel control knob, the acetone pressure should not exceed 15 psi. Note that the air valve must be closed. Thank you for your patience listening.